Hi everyone, I'm presenting TMI text-to-image meets image-to-image, our work on complementary data synthesis for long-tailed instance segmentation from LG Electronics AI Lab. Let's start with the problem. Instance segmentation needs large, densely annotated datasets. On LVIS, the distribution is severely long-tailed, over 200 categories, but 337 are rare, with as few as 1 to 10 images each. Reweighting and balanced sampling ease the imbalance, but they can't fix the core issue. Rare classes simply lack data. Generative synthesis is a promising fix, but prior work has complementary flaws. Text-to-image methods like mosaic fusion give diverse scenes but noisy pseudo-labels, while copy-paste methods like XPaste and Divergen give accurate labels but unrealistic objects, and targeting rare classes with pasting can even hurt accuracy. Our key insight: each method's weakness is the other's strength, so we couple them. The T2I branch brings broad diversity, made reliable through teacher-student adaptive pseudo-labeling. The I2I branch, VRAIN, brings realistic, accurately labeled rare class edits. Together, the hybrid keeps the diversity of T2I and the precision of I2I. This coupling shatters the previous performance ceilings on LVIS. Here's the framework. On the left, we generate two datasets. T2I samples category sets and prompts a text-to-image model for diverse scenes, while VRAIN edits real images to insert rare class objects, verifying each insertion for exact labels. On the right, a student model learns from both T2I labels come from an offline model plus an EMA teacher that adapts throughout training, so labels that start out wrong get corrected over time. Here, initially unlabeled sparkler is correctly annotated at a later iteration. For T2I, we sample classes, write a prompt with GPT-4o, generate with flux, then apply text-consistent filtering, keeping a detection only if its class was actually requested. This retains valid low-confidence rare instances, lifting rare class AP from 24.0 to 32.1. VRAIN is a two-stage place and verify pipeline. A vision language model picks a rare class fitting the scene and writes an edit instruction. An editor performs it. We then verify localizing with SSIM difference and open vocabulary detection, confirming with a VLM check, segmenting with SAM, and resolving occlusions. The result is a realistic edit with a trustworthy label. Why teacher-student? A static labeler trained on real images fails on generated ones, especially on rare classes. Our EMA teacher gradually adapts to the T2I domain and produces cleaner labels. It uses adaptive per-class thresholds, treats confident off-prompt objects as unlabeled for localization only, and merges online labels with a stable offline baseline. And because it also trains on the rare class 1-2I data, it learns to label rare objects in T2I images too. You can see the labels visibly improve over training. Now the results. Our hybrid beats real-only, T2I only, and copy-paste baselines across RESNET50 and SwineDage-L. Overall box AP improves 3.6 points on RESNET50, rare class AP by nearly 10. And on SWIN-L, rare AP jumps from 41 to 49. One more finding. Rare class targeted generation can backfire without realism. A rare-focused Divergen variant actually decreases rare AP below baseline, while our rare-focused VRAIN reliably boosts it. This matters practically. If a detector underperforms on a class, naive copy-paste can make it worse, while our method can reliably fix it. Here's why verification matters. The instruction here was to add a headset. On the left, the editor generated a helmet instead. Our VLM check catches this mismatch and rejects it. On the right, the headset is correctly added and accepted. Removing this step drops rare AP below real only. Our full VRAIN improves both overall and rare class AP. On the teacher-student side, the adapted teacher recovers rare classes like Dove and Walrus that the offline labeler missed. Using only the offline labeler gives stable but limited adaptation. Combining both gives the best overall AP. To wrap up, we presented a unified framework where T2I diversity and I2I precision reinforce each other. VRAIN's place and verify editing yields trustworthy rare-class annotations, and the teacher-student loop ties it together. We reach state-of-the-art on LVIS, and it scales with backbone size. Thank you.